Hello and welcome to today's video. Today we will be looking at the binomial theorem, and as a subtopic we'll cover Pascal's triangle. Binomial theorem is a technique that we use in mathematics in order to multiply any algebraic expression to the nth power without necessarily expanding the brackets. It's going to be easier if you have an example. So let's say we're working with x plus a power n. So what we do is that in binomial theorem, all we need to know is the value of n, the value of x, and the value of a, and we can expand the expression without opening brackets. For example, if n is 2, then what we'll have is x plus a power 2, right? If you want to open this up, you will have x plus a and then another x plus a, which gives x plus a, and then plus a, x plus a. When we open it all up, we have x squared plus ax plus ax plus a squared, which gives x squared plus 2ax plus a squared. So when the power is 2, we were able to get our answer in 4 steps. But what if the power is something more than 2? Let's say n is 5. What we would need to do will be x plus a power 5, which is x plus a okay, this is 1, 2, 3, 4. We still need a 5th one. You'd agree with me that this is quite tedious, and we can't start going through expanding each of the brackets one after the other. So that is where binomial theorem comes in. It gives us a way to go directly from this to whatever solution it will be without expanding all these brackets one after the other. And the first step to being able to successfully use binomial theorem is to understand Pascal's triangle. So that's what we're going to look at in this first part, and then subsequently we'll see how we can apply that to the binomial theorem itself. Pascal's triangle is quite simple. It's almost like a kid's game, and you can go on and on for as long as you want. It starts with the number 1. On the next level, you write 2 1s. The idea is to add the 1 or 2 numbers that are diagonally above the number. So in this case, you just have the single 1, and so 1 plus nothing will be 1 on this side and 1 on the other side. Now we're going to the next level. 1 plus nothing will be 1 on this side. This 1 plus this 1 will give 2, because 1 plus 1 is 2. And 1 plus nothing will be 1 on this side. Let's go to the next level. Again, 1 plus nothing will be 1. 1 plus 2 will be 3. 2 plus 1 will be 3. And 1 plus nothing will be 1. Pause this video and see if you can go one step further. When you're done, come back and we'll see if you got it. Okay, welcome back. So for the next level, we have 1 plus nothing is 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. and 1 plus nothing is 1. As you can see, the deeper or the lower we go with the levels, the triangle forms more clearly. Now, what do each of these levels represent? Right now, based on our illustration, we have 5 levels. We have this level, we have this level, we have this level, we have this level, and then this level. Each of these levels represents a corresponding value of the power. Remember, we have our example here, x plus a raised to the power of n. So each of these levels represents power n. And so the first level is 0, the next is 1, and then 2, 3, 4, and it keeps going down. For good measure, let's see what level 5 for n power 5 would look like. We have 1, we have 5, we have 10, we have 10, we have 5, then we have 1. So this is what n power 5 looks like. The next thing to look at is what each of these numbers mean. Again, on the first level, which is level 0, we have just the number 1. On the next level, we have 2 ones. On the next level, we have 1, 2, 1. Then we have 1, 3, 3, 1. We have 1, 4, 6, 4, 1. We have 1, 5, 10, 10, 5, 1. So let's say again that n is 5, which means we have x plus a power 5, right? Remember, from Pascal's triangle, that would be level 5, which is what we have at the very bottom. Each of these numbers, 1, 5, 10, 10, 5, and 1, represent the coefficients. Remember that when n was 2 and we had x plus a power 2, the answer was x squared plus 2ax plus a squared. Let's look at when n is 2 on our Pascal triangle. We have 1, we have 2, and we have 1. Coming back to the result, you see that the coefficient of x squared is 1, the coefficient of ax is 2, and the coefficient of a squared is also 1. Same thing applies for x plus a power 5. It just tells us that the coefficient of the first term will be 1, the coefficient of the second term will be 5, and the coefficient of the third term will be 10. The coefficient of the fourth will be 10 as well, coefficient of the fifth will be 5, and the coefficient of the last term will be 1. Now that we've seen how the Pascal triangle helps us, let's move over to the next video where we'll put it all together.